there's been a lot of discussion recently about encryption and the breaking of encryption and people looking at your web traffic and sniffing your web traffic and looking at your emails, et cetera, right? So encryption, another thing you're going to learn today, don't say SSL anymore. Say TLS. SSL, you'll get mocked if you say it. Say TLS instead. SSL is the old broken one. SSL v1, 2, and 3. The new hotness, the new awesomeness is TLS. So you'll be super popular at a party if you tell somebody that. So TLS is what you should be talking about. TLS is a way of encrypting traffic, right? You're encrypting from A to B. And I could show you you probably have all seen the Alice, Bob, Mallory wants to talk to each other and they have keys and all that. It's like in the old textbooks, but I'm not going to talk about that today. I just want to talk about some of the problems with TLS. The biggest problem I think about TLS is the number of root certificates. So the way TLS works is you have this kind of like chain of trust, like the circle of trust. If anybody's seen like Meet the Parents, like you're in the circle of trust. So you have, the way it works is like, if I want a TLS certificate for example.com, I go to a certificate authority, like a GoDaddy or a Symantec or a VeriSign or something like that, and I buy a TLS certificate, right? Everybody's done it, right? Is there like from $5 to like $1 billion? There's different classes of TLS certificates I'm not going to get into, but the reason that works is that certificate has been signed by a known root CA, a known trust authority. So in your browser today, you have like, depending on what your browser is, have like 50 to 200 of these root CAs. These are trusted authorities that can generate a TLS certificate. So when you, the browser, type in www.example.com and you go to example.com and that TLS certificate is presented, if it was signed, if your browser sees that TLS certificate was signed by a known certificate authority, it will trust it. And if it matches the name, right? TLS certificates also have a name in them, like example.com. So if you try and go to whitehouse.gov and they present an example.com certificate, you've probably seen that before, right? You'll get a certificate error. Or if you try and go somewhere where it's a self-signed certificate or a certificate signed by an authority that the browser doesn't trust, you get an error, right? There's actually some cool talks out there about like the error message of you know how you get that where it's like, this is an invalid certificate. Are you sure you want to continue? There was like a whole UX study about how to do that. Search for like Google browser warning talk something or other, not the something or other. But basically, there's 50 to 100 plus companies out there that can generate a certificate. The harder part is that any CA can generate a certificate for any domain. So let's say you're apple.com and you only ever buy your certs from VeriSign. An attacker sets up a fake Apple site and is able to compromise any other certificate authority out there, can also generate a certificate for apple.com and make it look like Apple generated that, right? Previously, Apple did not have a way to say that only trust this certificate or only trust a certificate signed by this certificate authority. Like Komodo will never sign a certificate authority for me if I'm Apple, only ever trust Symantec, right? That's how a lot of these, like if you look at like Stuxnet, anybody read much about the Stuxnet attack? There's a killer book on that. It's like Countdown to Zero Day or whatever. Like if you like anything to do with security, it's such a cool book. But it's talking about Stuxnet and how when the alleged U.S. government was able to compromise the computers at the Natanz reactor, they were able to generate a certificate for the Microsoft's code signing certificate by compromising a completely unrelated certificate authority. Doesn't that seem like a problem that like some random certificate authority could generate a certificate for Microsoft, right? That seems like it's kind of a problem, right? So that's the problem with TLS right now, is there's so many CAs out there. And there's no like trust that says that only this certificate authority can generate a certificate for this company. But now what they're doing is they're starting to come out with new ways of doing that, and that's what I'm going to talk about here. Because there's a lot of talk about like, make sure you use TLS to encrypt your content. It's kind of boring. This, I think, is a little bit more interesting, especially as developers. I think you'll think it's cooler. So I'm not a cryptographer. It's like, I don't know, that's not even related to being a cryptographer, but I thought that was a hilarious function from XKCD, like get random number, just bask in it for a second, read it. Right? Guaranteed to be random because you rolled the dice, but Get it? Everybody get it? See what he did there? All right, thank you. So, I put this in there because I know there's a big talk about microservices in a lot of the talks, so I had to be cool and put microservices in my slide. But really, if you think about it, you want your microservices to be secure, right? When microservice A is talking to microservice B, you want some level of validation that it's talking to the right microservice and that there's encryption. Did you hear that? Weird. That there's encryption of the content between the microservices, right? That might be credit card data, right? That might be personal PII, right? If you're PCI compliant, all your payment data has to be encrypted in transit all the time, right? So if you're talking to if your microservice A is talking to microservice B, those are two very cool things that you can do and that you can use TLS to do. TLS allows you to do verification of that this client should be talking to this server. I don't know, most people don't realize that. Like a lot of people write these really complex API authentication mechanisms like for microservices behind the scenes. TLS and PKI is actually a really good way of validating a client with a server. Like a client can have a certificate and a server can have a certificate, and they can validate each other using those certificates, right? I don't have to write 400 lines of Ruby code every time I want to write some new client server verification system, right? TLS actually will do that for you, and it's a pain in the ass to get people to install client certs in their browsers. But it's a lot easier to do client certs when you control the client, right? Like some sort of API, like I'm using microservice a lot because I want to use the buzzword. But right, if you got two things talking to each other and you control both ends of that equation, TLS and PKI is actually a pretty cool way of doing that. Anyways, there you go. There's my microservices talk. All right, so pinning. This is where it gets kind of into the nerdery. I apologize to some of the crypto stuff, but it's actually kind of interesting where remember the problem I told you about where Apple can't say that only VeriSign generates its certificates and not Komodo or GoDaddy or anybody else? Key pinning actually allows you to give the browser a hint of what certificates or keys are legitimate for this site, right? You actually are setting this via a header, and I'll talk about it in a second with Dane, where it's like a DNS record, but you're actually via headers telling the browser what CAs should you trust to generate a cert for me. Now you might say, well, how is that? What if they compromise the site? Can't they publish the illegitimate CA? Well, yes, but Chrome, Firefox, and Safari actually have this, I'll show you in a second here, where it's at HSTS, where both the pinning data, and I'll talk about HSTS in a second, is actually in a list that gets distributed out with Chrome. So all the most popular sites on the internet, like Facebook and Twitter and stuff like that, their pins and their HSTS settings are actually replicated out via the browser so that when your browser goes to a site and pinning has been set, and the other beauty of it is pinning is cached. So let's say here, let's walk through this for a second. I go to twitter.com with my Chrome browser. Twitter says, and I'll show you HSTS in a second, but just bear with me. You should only ever do this over SSL. You should only ever go to me, twitter.com over SSL, and you should only trust this certificate authority. That's the first time you go, okay? So now, time goes on and Twitter gets compromised. And they serve a new certificate, right? Because they weren't able to, let's say, steal Twitter certificate. They redirect you to some other site. I now know that this cert maybe was generated with a different CA, so that'll be wrong. And then maybe they're not even going over SSL or mock me. Come on, mock me. I said SSL, mock, thank you. They're not even going over TLS anymore, right? So, and I know this is really late in the day for me to talk about crypto and stuff, but it's really kind of cool stuff PKP doesn't have a good ring, so they called it HPKP, even though it's public key pinning for HTTP. Another little known fact for you. So HSTS, I'm going to skip over just to this one a little bit. What HSTS is, this one's kind of cool. Let's say you always want your site to go over TLS, right? Your bank or whatever. You never want an end user to go over HTTP, but what happens? Those dang end users always type in example.com. And it goes over HTTP to start with, right? Then what do? I put a 301 or a 302 redirect to my SSL site, right? Because the end user never types https://example.com. So what HSTS is it's a way for you to flag to the browser that it should only ever go to you over TLS. Dang it, TLS. It's a lot of years of saying that word. So don't mock me. Mock everybody else. Just don't mock me. So HSTS will actually it's a header that gets sent back that says only ever go over to this site via TLS. So maybe the first time you went to that site over HTTP, from then on your browser will cache that you should only ever go to that site over TLS from then on. Yes?
Can you use that on a URL basis or is it site-wide?
It's on a domain basis, yeah. So you can say, like, it's kind of cut off right here, but see this flag right here includes subdomains. That's where you would say anything under example.com. Use HSTS, not just example.com. So anyways, and what happens is, so the browser caches this, and like I talked about, and you can see, like if anybody's about Chrome, you can see all the HSTS sites you've actually visited by going to this debug URL, and Chrome will, yeah. They're adding it. It's not widespread, but they're adding it. Yeah, exactly. It's a good question. I mean, so if you didn't hear, sorry, he was asked if it's supported by things besides browsers like curl or like the Java, HTTPS lib or whatever. They're adding it as time goes on. But basically what you're saying is always and so the browser will cache this information. So from then on, it will go over TLS. And like I said with the pinning stuff, the more sensitive sites on the internet, they're on a list that Google automatically sets HSTS for no matter what from then on, right? So they'll only ever go over TLS. It's kind of cool. So yes?
So what happens if you change your mind later? Is there a time limit for that?
That's a very good question. If people have been bitten by this before, I've seen folks set this max age, that's how long to trust it for or to set it for. I've seen folks set HSTS, and then it was broken or something, and then they turned it off, and then their TLS was broken, but everybody kept going to over TLS because the HSTS setting said to keep going over TLS. So with anything in this world in computers suck sometimes, don't they? But with anything in computers, like things break. You have to be careful when you do stuff like this. So be careful when you do these things. Just know what you're doing when you do it and whether it will cause a whole lot of pain. So like Python, so they're on us. There's a site, a cool site, yes. You go to, there's a site that Google maintains, a couple of the folks there, that you set HSTS first, and then you submit your site to it, and then they will include it in that list that they start to replicate out. You put in the domain, and it will do some testing and stuff. So I forget the exact URL, but if you search for like Google HSTS submit, I think there's a form that you do it. But so Python. There's another cool site. Write this down. It's called SSLlabs.com. If anybody's been there, you put in your domain and it will test the strength of your SSL. Dang it, TLS. I still do it. No, that's the thing. He needs to change that site. Good point. But you go to SSLlabs.com. He may have registered TLSlabs.com by now. I really hope he has. But what you do is you put in your domain, they'll run a test, and it'll give you a nice little grade of like good or suck. But no, it'll be from like A to F. But go check out all your sites. And if it's not an A, shame on you. It should be an A. It's really easy to get an A now. HSTS is something that will give you an A+. So even if you've set all the cool stuff and you don't have HSTS, you can only get an A, but you can get an A+ if you set HSTS, and that's Python. They were all excited. They got A+ on theirs. So, okay, so there's two more things, I promise, and you can go and you can be like, that was horrible. Certificate transparency. This is another Google project that they've launched where they publish an audit log using a Merkle tree, which if anybody knows Merkle trees, I don't. I just like to say the word Merkle tree because I sound smart when I say it. Where they'll actually put the fingerprint of certificates that they see in a public log. And CAs will put the certificates that they generate into a public log. Why is that interesting? Because now, right, think about like the Stuxnet compromise, right? Like the rest of the world was fine, but there were just like a small percentage of computers that had this illegitimate certificate, right? If there was a public log that those computers could have submitted to, that rogue certificate would have been seen early on, right? Let's say that you've been compromised on your laptop because you went to a site and you accidentally clicked on a link because you thought it'd be awesome and it was a video of cats or something like that, but really it was malware and they hijacked your computer and they installed like some illegitimate certificate for wellsfargo.com. Not that I've ever done that. If like now my computer's compromised, right? If that, when I go to that wellsfargo.com, if there was a log where I submitted the fingerprint of that illegitimate certificate, like wellsfargo.com could be looking for people compromising their site or compromising their certificates, right? So what this is really just doing is they want to have this public log of all the certificates that are seen out there, and eventually Chrome or browser could start to use that to decide if this is a legitimate certificate or not, right? If I'm Chrome and I go to wellsfargo.com and I check the public certificate transparency log and it's not the same certificate that 1,000 other people got before me, maybe I throw up an error, right? There's a lot of cool things you can start to do once you have a log of all the known and illegitimate certificates out there. And this is actually really important because EV certs, anybody have EV certs? Do you know what an EV cert is? You pay a whole lot of money to have like a bigger green. So like if you go back to that, see that? That's an EV cert. So instead of just being a green padlock, Python has their own name right there in the browser. There's a lot more vetting that's done to make sure it's the legitimate org buying the certificate, right? So with EV certs, you'll have to have, to get Chrome to recognize an EV cert, you have to have a certificate transparency log entry. There's nothing that really you all can do today except to pressure whoever you buy your certificates from to, when they generate your EV cert, put the fingerprint into the log. So this is Google kind of doing what they do, which is kind of, they can use their clout to get the internet to be more secure, right? They're basically saying, look, the internet will be more secure with CT, and so we can use our clout of having this browser of Chrome that so many people use, and forcing anybody who buys an EV cert to put their log entry into the certificate transparency log, right? So it's kind of cool. Anyways, I think it's cool. Dane. So this is the last thing I'm going to talk about. Yay, they all said. Dane is basically a way of doing what I kind of talked about. I'm going to skip over that slide because it's boring. With DNS. Right, so what you're doing is, remember how I talked about it'd be cool to be able to say, see this certificate that I'm using for my example.com site, this TLS certificate? You know how I can tell you that it's legitimate? Because I'm going to use DNS to put the fingerprint of I'm going to put the fingerprint of that certificate in the DNS so that when you load it with your browser, you also check the DNS to see if those certificates match. So now the attacker not only has to compromise the website, they have to compromise the DNS provider as well. Anybody here know what DNSSEC is? Sorry that you do, because it's DNS, crypto, mash them together. Not so fun. But basically what DNSSEC is a way for having guaranteed answers, is what the promise of DNSSEC is. When I query for www.example.com and I get an IP address back, it's cryptographically signed such that I know that is the right answer. So if I can guarantee the results of a DNS answer, I can start to put TLS certificates in the DNS. And now the browser can check both the certificate I was presented by the web server and the certificate I got back, the fingerprint of the certificate I got back from the DNS. Do they match? And if they don't, that's a problem, right? So there's been a lot of people said like, so what you're saying is, in theory, and this is going to blow your mind, prepare. Do I need the GoDaddies of the world anymore if I can self-sign a certificate, put it in the DNS, the fingerprint of that self-signed certificate in the DNS, and then I only have to use a self-signed certificate, right? I no longer need the validation of the certificate authorities, right? I just put this fingerprint of the DNS of myself in the DNS for my self-signed cert. The browser goes to my site, it sees the self-signed cert, checks the DNS to make sure this is really what I meant to have as my TLS certificate, and everything works fine, right? Well, no, because DNSSEC won't have, you have to have 100% DNSSEC adoption for that to work. That isn't going to happen for a long time, ever, whatever. So like there's no threat to the certificate authorities, and certificate authorities actually provide other value as well. So but that was one of the fears of DNSSEC, was that it would completely destroy the certificate authority market. And we're like, whoa. We're hiring, so come join us, please. Anyways, that's my talk. Who has questions? Yes?
What do you think about self-submit cookies as opposed to,
Are you talking about for like CSRF protection? So the question was cookies for CSRF protection, et cetera. The problem with cookies are they're controlled by the end user or the end browser, so you can't trust them is the problem, right? You can't trust. So the cookie can only, you have to have a nonce on this side, the server side, and a match coming in from the client side. You have to be able to match those two. If you're only trusting cookies, you've only got one side of that equation. So if you go on that OWASP page that I referenced, like they go through the very detailed of why cookies are not a good idea for CSRF protection. The best protection is on every form generation, generate a new token, and then look for that token when the form is submitted, right? That's how you should do it. There's no other foolproof way of doing it. Everything else has flaws. Yes? No, that's a good question. So the question was on, is HTTP2 going to make my slide talk obsolete and make me even more mocked? That's his exact words. No, HTTP2 is similar enough to HTTP1. I mean, it changes some things like, how many here do domain sharding when they like generate like host names on the page for images, right? Because a browser only opens X number of sessions to the server. So HTTP2 uses multiplexing, so there's only one connection to the server, and all requests go over that single connection, and it's multiplexed, so there's no blocking or whatever. Now, there's some concerns about that with performance and such, but so that'll actually help fix that. I mean, most of the HTTP2 things are built around some performance things, not around security and encryption. One of the things that HTTP2 is trying to do was some folks wanted it to be mandatory to use TLS with HTTP2, so like force people to use, if you use HTTP2, it has to be over TLS, right? If you think about that, that just makes every site on the internet now have to support TLS, which is good and bad, right? I mean, it's good, but it's also bad in that there's a lot of misconfigurations out there. So HTTP2, what actually turned out to be was I think Firefox and maybe Chrome are gonna force you over to TLS if you use HTTP2, but Safari and whatever Microsoft calls their browser these days, I guess they're sunsetting Internet Explorer to call it something else. There's enough negative connotation on the term Internet Explorer that they're killing it. They're not going to force TLS, so there's nothing there. But all these security thingies, like they're all relevant even in the HTTP2 world. HTTP2 is really a change in the kind of like the transport protocol of HTTP. And we're a long ways off for HTTP2. I mean, there are a lot of people. Whoa. Bump the button. There are a lot of people that are implementing it. We've held off a little bit because there was some like DDoS vectors around header compression and such that were a problem, but we'll implement it as well. We've just been kind of slow and watching it kind of get some actual traction before we do. What other questions besides, am I done yet? Yeah. Yeah, it's a good question. So the question was, is all this security stuff going to affect performance? Most of it, no. I mean, those headers are sent back anyways. There's a little bit more computation when you're trying to compare like CSRF, the two tokens. I mean, it's very minimal. Everything going over TLS, I mean, crypto adds some level of increased computation, right? It's crypto. It has to do something, right? There's got to be a reason for it to be secure. I mean, it's just more CPU cycles. But if you think about like, there's a lot of cool technologies like with things like TLS false start, so Google that later, session resumption, et cetera, that make TLS not nearly as computationally intensive as most people think it is, and makes it actually, just a very small bump up in CPU usage, et cetera, and memory. So it's well worth it for the security benefits that you get for all these, for the small performance degradation you might get. Yeah. I promise I did not pay him. He said, how hard is it to adopt these practices while using Fastly? Well, we won't do it automatically for you. What we have we just give you some tools like using VCO. You can auto set the headers and stuff. So we'll help you. Like TLS is super easy. Like we'll terminate, and I'm trying not to sound salesy, but he asked, and I promise I don't know him. This is like an infomercial, like, why are you so awesome? But basically, like TLS termination, right? Instead of you having to terminate, like the guard, I mean, we have a lot of sites that get a ton of traffic that are now using like CNNs on us, et cetera, right? Like getting all, that's a lot of TLS traffic to terminate. That's like hundreds of thousands of connections a second that they would have had to terminate. CNN's not using TLS, actually, that's a bad example, but like let's take like New Relic or anybody like that posts a ton of traffic to us. We terminate those TLS sessions for them, and then we have a few TLS sessions to their backend. So they only have to scale their backend up, and a lot of CDNs will do this. I shouldn't say any, but a lot of CDNs do the same thing. Like, you only need to have a couple of TLS sessions with your CDN. The CDN will terminate all of your end user sessions, which is kind of cool, right? So even if you're getting a metric butt ton of traffic, you're still getting the same number of requests to your origin. The CDN is the one taking all the traffic. That's why I always recommend people use a CDN, like not just for your static assets, but in front of your dub record as well. We can scale way bigger, faster, cheaper than you can. Just build your origin to handle what you need, and then we'll handle all the rest for you. So sales mode off. There. Any other questions? Yes. I think some of the frameworks, like Spring and some of those others, have it built in. I don't know as much about Java. It's just been a long time since I've done Java, but there's so much stuff out there written in Java, I guarantee that most of the frameworks do. Or if they don't, there's probably some Java lib that you can include. So I'm pretty sure, yeah. Anybody else? Thank you so much for coming to this talk, the last one of the day and this and of the whole session. So hopefully everybody travels safe, and thanks again. So.